Resistors The Series, which is actually about resistors in series. What am I talking about? Resistors one after the other. Resistors in series. Sounds simple enough. In a circuit, you're going to find resistors in series, one after the other. So what's that mean? Well, I suppose it can be used to increase the resistance. Say you've got like I say, if you've got a small space, use a small resistor, but if you use 3 resistors, I'll just use one larger one. I don't know. There may be practical reasons. I'm sure there are, and I'll get onto that later. So, first of all, 3 resistors in series, one after the other. I've got here 3 resistors, and they are, looking at my colour chart, a brown grey, I think that is. Black, brown. Brown, grey. 180 ohm. And I have another 180 ohm. And then the last one I got here is brown, red, orange. That's a 12k resistor. So what am I going to do with these? Well, I suppose I'll have a quick look at the mass, because there is some mass to go with it. Like I said, there's always mass with electronics. We'll just try and keep it down to a minimum. How do I know what the total resistance is going to be? If I've got 2 resistors, that's how I draw resistors. Other people might draw it like that. But never mind. 2 resistors joined up together. On this side we're going to have, let's say, 12 volts. And this is 0 volts. Or you might see this more conventionally drawn, I suppose. It's 14. What am I doing? 14. 12 volts. Zero volts. And let's take it on the common value. Something we see all the time. Brown, black, brown. 1, 0, 0, 1. Which is a 1k, 1000 ohm resistor. They're 1%ers. 1k. I've got 12 volts, so what's the first thing I could do with this? I could work out the current. Let's have a look at the current. Equals voltage. Is it divided by resistance? So a quick look at that. Yeah, so what have I got? Let's write this down. I've got 12 volts and I got 1. Now, this is the thing. How do I get to know what that resistance is? Well, resistors are pretty easy when they're in series. Apparently the equation for it is your R total equals R1 plus R2 plus R3, etc. for as many resistors as you have in series. So you just basically add them up. So with this one, I'm just going to add up the 2 resistors. So on this one, our total equals R1 plus R2, which equals 1000 plus 1000, which of course is going to be 2000. 2k ohm. So going back to this here, 12 divided by 2k. So we got 12 divided by 2000. So my current equals 0.006 amps. So what have we got over here? 12 volts, 2k, 6 milliamps. You know, this is looking pretty simple. What else can I do with this? That's just so simple. Resistors in series are added up, and we know now what the current is going through those two resistors, what the total current resistance is, and the voltage I got at the start. Well, okay, let's have a look and say, well, with this circuit, there's current flowing through it. Now, the current that starts there is going to be the same as there. And we know from potential difference that the voltage that's 12 volts there is now 0 volts there. So where did that voltage go? So there's some voltage lost across there and some voltage lost across there. I suppose really we should be able to work that out, because if the current stays the same all the way through, then we can work out what the voltage is across that resistor. So what we're saying is volts, 1k, 0 volts, and we start with 6 milliamps. So that same 6 milliamps is going to travel through there, going to go through that resistor and then through that resistor. So I know that if I want to work out the voltage, that's the current times the resistance of the resistor that we're looking at. So this is R1, R2, R1. So if we say that, we'll go, ah, that's simple enough. 0.106 times by 1000 means that has got 6 volts across it. So if I got 6 volts, and that means we lose 6 volts if I was to measure across there. At this point, it would say 6 volts. And if we do the same here, that's the same resistance. So that's going to have 6 volts drop across it. So by the time we get to here, we have 0 volts. Marvellous. You know what? That is so simple. What if I've got different value resistors? Well, that shouldn't be a problem, should it? Let's say I've got that 1k and I've got one of these 180 ohm resistors. Got 12 volts there and 0 volts there. Now the first thing I did before was to work out the current, because the current will be the same through the whole circuit. So current equals V divided by resistance. First of all, we need to work out total resistance. R total equals R1 plus R2, because we've got 2 resistors in this instance, so we've got 1000 plus 180 equals 1180 ohms. Let's call that 1K18. That's the total resistance. So we can work out this now. Voltage is 12 divided by 1180. 12 divided by 1180. So current equals 0.01. We won't really round it up any more than that. So that is 10 milliamps from there to there through the circuit. So now I can look at this and go, well, let's work out the voltage that's being dropped across this resistor first. So we now know that we have voltage equals I times R. We know that we've got 10 milliamps times by 180 ohms. 0.1 times by 180, 1.8 volts. So across that point is 1.8 volts. So actually, if I look at this and go, well, I've got 12 volts there, I lose 1.8 volts there. So I could say 12 minus 1.8 equals 10.2. I'm saying that across R1, I'm going to have 10.2 volts. Let's just write that down. And then I'm going to go through that and calculate it using this for R1. So I'm saying, just write that, R2, voltage equals current times R2. In this instance, we've got 10 milliamps times by 1000 ohms. 0.1 times by equals, now this says equals 10 volts. So there's a slight difference there, because it's saying that even though I've got 12 volts, I've got 1.8 there, this is 10 volts. It's got a 0.2 volt variance. Well, you know what? I'm not so worried about that. To me, I've counted for the current through the circuit, total resistance, voltage and current there going through will give me the voltage there and the same there. Now there is a slight variance. I suppose I'll learn about that at some other time as to why I've got a variance. To me, I've done the calculations that I feel are alright. So that's not R2, that's R1, isn't it? R1, R2. So let's actually do that. Let's have a look at this and make sure that I'm doing this right. Okay, here we go. The circuit. I can't really see it. Let me see if I can zoom in. There you go. A couple of resistors on the breadboard just linked together, so they're actually in series. And we've got two. I'll get this set up. There we go. It's better. Two meters here. This one's reading the current coming into the circuit, and this one we're going to measure the voltage across the resistors. So let's turn it on. We've got 12 volts. And I'll prove that because I will measure across the input point and the output point, which is 12 volts. I got 6 milliamps, and that, with these 1k resistors, is what I calculated. So I should be able to show that I've got 6 volts across the first resistor and 6 volts across the second resistor in series. Can't go wrong with that, can you? What if I change out that resistor for the 180 ohm resistor I calculated for? So let's have it. Yep. brown, grey, black, black, brown. Bend the legs. Bit haphazard on doing that, but never mind, as long as it does the job. And put that one in. Now, this time we calculated it was going to be, what did I say it was? I calculated 10 milliamps across the whole circuit. So let's turn it on and have a look. There you go, 10 milliamps or about. We still have 12 volts across the whole circuit. But I also calculated that I'd have 1.8 volts across this smaller resistor R2. So let's have a look at that and see if that's what I've actually got. 1.82. But I also calculated that I'd have 10 volts across the first resistor R1. 10.17. So actually it works out about right. There was a slight discrepancy in the voltage, but for me that's good enough. Resistors in series. Now I suppose the other thing about this is power. Am I going to blow these things up? Am I going to burn them out? Are they going to go up in smoke? Well, what I'm going to do is I'm going to put another 180 ohm resistor in there. So I've got 280 ohm resistors. I'm just going to turn it on without calculating the power. And see if we get magic smoke. Suppose we could work out what the current's going to be first. What have we got? We've got two resistors. Let's do this on the fly. Got two resistors, 180 ohm. So if I can get an angle on that, 180 times by 2, 360 ohms. So if I want to know what the current's going to be, it's 12 divided by 360, 33. I'll call that 33 milliamps, 0.033 amps. So if I times that by the current, by the voltage, should tell me the wattage, 0.4. But if you think about it, that's split over two resistors, divided by 2. So each resistor is only going to have to deal with 0.2 of a watt. They're quarter watt ratings, so it should be able to handle it. So let's just turn it on and see, eh? Oh, stay there. Change my range on my multimeter. So overload on the current range. Look at that, 32.6, nearly 33. And then we're going to measure the voltage across the whole circuit. Still 12 volts. The voltage across the first resistor. And remember, these two resistors are the same value. So actually, there's another thing to do with resistors in series. If they're the same value, you can just halve the voltage or divide it by 2 because it's just going to be the same. So again, 6 volts. And across R2, 6 volts. You know, that all seems to work just fine. So there we go, resistors in series. Seems to work for me.